Hello and welcome to Algebra 1, Chapter 9.2, and today we're going to discuss solving quadratic equations by graphing. And there, in 9.1, we just talked really about graphing quadratic equations, and so now we're going to have a purpose behind our graphing. And there are going to be 5 ways of solving quadratic equations. You're going to have to know all of them. So the great thing is that you already know 2. So ways to solve. So way number 1 is by factoring, which is most of what we did in Chapter 8, and that uses the zero product property we talked so much about. Okay. Way number 2 that you know then is using the square root property, which you know about from the end of Chapter 8. Okay, so in 9.2 we're going to learn way number 3, and that is by graphing. Alright, so remembering that a quadratic equation is anything that has an x squared in it. So ax squared plus bx plus c equals 0 is going to be our equation we're going to use to graph. In the past we've had y equals, and then remembering that y equals and f of x equals are the same thing. This is just telling you that it is a function. Okay, so being a function, it's going to pass the vertical line test. And so we're going to set it equal to 0 and we're going to graph it. And the reason that we're setting it equal to 0 and graphing it is so if I'm making y become 0, where on a graph does y equal 0? On the x-axis. All of these points on the x-axis have a y of 0. Those are my answers. Okay, so my answers, otherwise called my roots or my x-intercepts, those are my solutions to a quadratic equation. So when you solve by graphing, your answers are your x-intercepts. So the goal of us graphing these is to find our x-intercepts. So let's start with negative c squared plus 5c minus 4. And we're going to graph how we were taught to graph in 9.1, and that's by finding your axis of symmetry first. So x equals negative b over 2a. Keeping in mind that a parabola is symmetric, this will help you define this first. So a is negative 1, b is 5, and for the sake of it, c is negative 4. So we get negative 5 over 2 times negative 1, which is negative 5 over negative 2, or positive 5 halves. So when I start my table, if I start with 5 halves, or you can make it 2.5 if you want to, that's my vertex. And I'm going to plug it back into my original equation. I'm going to be really careful with that negative sign, because this is going to be negative 5 halves squared. The negative does not get squared. Plus 5 times 5 halves minus 4. And we get 2 1/4 or 2.25. Make sure you can get that answer. Okay, so 2.5, 2 1/4 would be about there. And from our previous conversations, you should know that this parabola is going to open down, which is good to know at this point because if it opened up, it would never cross the x-axis, and if those are my solutions, it would not have any. So this does open down, and so maybe we just try 2. And for 2, we get 2. And the goal is, where is this going to cross the x-axis? So if I type in 1, I get 0. So there is one of my answers, and knowing that this is symmetric about this line, can you determine what the other answer is? I think the other answer should be 4. I'm going to check it anyway. 4 does give us 0. Okay? If it says solve by graphing, you have to have this graphed. So you need to go ahead and finish graphing it. And then you have to have our answers, and our answers are 1 and 4, because those are the two places where it crossed the x-axis. So there you go. There's your first one, solving by graphing. So let's look at another one. Let's go ahead and determine A is 1, B is -3. You're going to need your C later, so if you go ahead and start figuring out what that is, that will help you later. So we get -b over 2a, which is a -3 over 2 times 1, which is a +3/2. So that is going to be my vertex. And you're going to plug it into your original equation. Alright, and now you get -12 1/4. And that's okay that we're off the graph, because really I'm looking for where it crosses the x-axis. So yes, you need the graph, but it doesn't have to be perfect. Now this one is going to open up because A is positive, which is good because that's the only way it's going to cross the x-axis. And so you just need to pick one way, either go left or go right from the vertex, and just start figuring out points. Tell you what, let's go to the right. So we're at 1.5, let's go to 4. If we plug in 4, worked it out, we got -6. Okay, so I'm not yet to the x-axis, so maybe I do 6. Well, 6 gives me 8. So what happened? We passed it, so let's go back and try 5. 5 gives us... So if we know that 5 is 0, can we find the other 0 just by using symmetry? So our axis of symmetry was at 1.5. So that looks to be 1, 2, 3.5 to the right. So if we go 3.5 to the left, we have 1, 2, we should be at -2. You need to try that though. Don't just assume that that was going to work, because if you got the one on the right wrong, you got the one on the left wrong. So plug that into your equation, -2, and I do get 0. And then we have to draw it in. If it says solve by graphing, you have to have it drawn in. And then we need our answers, which is x equals -2 and 5. And order there does not matter. And that is a 5. Okay, so let's try again. So most of the time it's going to cross the graph twice, but it doesn't have to. So let's see here. X equals -b over 2a. So that's going to be a -6 over 2 times 1, which is 6 over 2, which is 3. All right. So we're going to start our table with 3, and remembering that that's our vertex. And we're going to put 3 in for x. Make sure you're working these out, because it's important that you know how to get these answers. So if you put 3 in for x, 3 squared is 9, minus 18 is -9, plus 9 is 0. So what happens when our vertex is on the x-axis? So this is going to be a case that you only have one answer. And that answer is the one place that it's crossing the x-axis. Now, I've said several times, if it says solve by graphing, you still have to graph it. So let's go ahead and do 2, 1, 4, 5. And get some points to graph it. So we're looking at 1 and 4 for those. So 2, 1, 1, 4, 1, 4. So there's our graph. So we have to have it graphed, but then when it comes to answering it, we only have one answer. Okay. By the way, I want to show you that you can solve these anyway. So if you solve this by factoring and you factored this, it would actually factor into x minus 3, x minus 3. If you did zero product property, you would set both of those equal to 0, which you really only need to set one equal to 0. Or you could use square root property on this one, because you could write it like that with a squared. And then when you square root, you'd get that same answer. Okay? So it doesn't matter how you solve it, you're going to get the same answer either way. But by factoring, though, we could have found out there's only one answer as well. Alright, so here's our last one that we're going to solve by graphing at the moment. Same thing, negative b over 2a, but not equal to 0. So what you have to do first is you need to subtract the 5 over and set it equal to 0. Has to be equal to 0 for you to get your a, b, and c. So I know that only affected your c, but it still has to be equal to 0. Negative 3 over 2 times a negative 1. Keep in mind here that this is going to open down, which is going to be positive 3 over negative 2, which is negative 3 halves. So I'm going to start my table at negative 3 halves for my vertex, and then put that in for x and see what you get. Make sure that you're doing negative 3 halves squared minus 3 times negative 3 halves minus 5. All right, so this is going to be a negative 9/4. Do not distribute first. Do not do that. Square your negative 3 halves. It's going to become a positive 9/4. The negative sticks on out front. Plus 9 halves minus 5. And I get negative 2 3/4. So at negative 1.5, we're going to go down to negative 2 3/4, so someplace around there. Now, this opens down. Is it ever going to cross the x-axis? It's not. So I already know that this is going to have no solution. That's my answer. You still have to graph it. So we still need to do negative 2, negative 3, negative 1, and 0. And get negative 3 and negative 5. Okay, still have to have it graphed. I'm going to give you points for that, and then we have here though is our answer because it never crosses the x-axis. We're going to switch gears here real quick and determine how many answers a quadratic equation is going to have by factoring it instead of by graphing it. And so this is what we were doing in Chapter 8 when you were solving using the zero product property. So keeping in mind that we've seen 3 different examples so far. We've seen where it crosses the x-axis twice, so that's going to have 2 answers. We've seen where it just touches, that's supposed to have just touched the x-axis, in which case it's going to have 1 answer. And we've seen where it doesn't cross the x-axis at all, in which case it has 0 answers, or you would say no solution. So you can tell this by factoring, because it's going to be how many answers you get with your zero product property. So if we factor this, I'm just going to use trial and error. X and x. What multiplies to be 25 and makes 10? Well, that's 5 and 5. This sign says my signs have to be the same. This sign says they both have to be negative. So if we set these equal to 0, how many answers are we going to have? We're only going to have 1 answer, or 1 root, because they're going to be the same. And then what is that root? It's going to be 5, because you're going to set x minus 5 equal to 0, and you're going to add 5 to both sides. So let's look at another one of those by factoring this. So again, with a leading coefficient of 1, I always just like to use trial and error. But multiplies to be 10 and adds to be 3. It's going to be 5 and 2. This sign tells us we're going to have 1 of each sign, and we need a positive 3. So if we have a positive 5 and a negative 2, that's going to make a positive 3. And let's go ahead and set them both equal to 0, because it does tell us to identify the roots. there are going to be two roots. It's going to cross twice, and those roots are -5 and +2. So the last thing we need to address is you're not always going to have whole numbered roots. And so the first 4 examples we did, well, 3 of them that had roots, very nicely crossed at a whole number. But that's not always the case. And so here's just a different set of directions. If they don't cross at a whole number root, you're just going to estimate by saying the consecutive integers it's between. So for example, if it crosses here, you're going to say it's between -8 and -7. Okay, so let's see here. So we're still going to graph it because you don't know ahead of time where it's going to cross. So -b/2a, -4 over 2 times 1, which is going to be a +4 over 2, which is 2. Put my table up here. So x, y, and my x is 2, and so let's plug in 2. So 2 squared is 4 minus 8 would be -4 plus 2 should be -2. So at 2, -2, and this opens up, so I know that I have roots, all right? So let's try 1. 1 gives us -1, okay, and then 0 gives us 2. So what happened, if it's 0 is at 2, then we have crossed the x-axis someplace between 0 and 1, even though my line does not look like that. Because if it's 0, it's at 2, and at 1, it's at -1. Let's see if I can, right, someplace between there. Do not try to guess where it is. So, but we need to do the same thing on the other side, and let's look then at 3 and 4. And at 3 it's at -1, and at 4 it's at 2. And so the same thing happened over here, is it's between 3 and 4. So if you get one that you don't have it whole number roots, okay, do not try to guess it. Just state the consecutive integers that it's between. So, 1 and 2 are consecutive integers. So what is it between? All right, so there's 9-2. That is our third way of solving a quadratic, solving by graphing. Remember, you're looking for your x-intercepts. Let me know if you have any questions, and if not, I will see you in class. Have a good day.